As you can see, we are currently doing structural analysis after the basic information of CCTV headquarters, site analysis, and presentation of foundation. Last week, we had a review of the angles of the diagram applied to CCTV headquarters. This week, we will learn about the elements that make up the tower part of CCTV headquarters. In the previous process, we looked at how the foundation and basement of CCTV headquarters were arranged. CCTV headquarters used a piled raft foundation, which combines the existing piled raft foundation. A column was raised on this foundation, and the column of CCTV headquarters used steel and SRC columns. SRC is a synthetic structure that combines the advantage of reinforced concrete and steel frame. And steel and concrete work together to improve load resistance and ductility. The SRC column shows superior performance compared to the RC column, and the result of the study showed that the performance varies depending on arrangement and type of internal steel. The SRC column improves the compression performance by 50-70% and the tensile performance by 400-800%. In addition, about 2,400 tons of high-strength steel bars called Q460 were used, which contributed to the expansion of usable internal space by being used in areas where loads were concentrated because the tensile strength was higher than that of regular steel bars but the weight was light. In a typical building, columns are arranged continuously, but in the case of CCTV headquarters, it was impossible to arrange the inner vertical columns continuously due to the tilt tower structure. Therefore, vertical columns separated according to the inclination were used and designed in the following form. In this process, unlike ordinary buildings, the horizontal distance increased as the height increased during the construction process. Since the material on the outer part could not be stably transported only by the vertical movement of the crane, the method of dismantling one crane with the other crane and transporting the material to the out part through horizontal movement was additionally used. The transport truss was also applied to withstand additional load. It was applied to the lower portions of the studio and cantilevers, which were particularly subjected to greater load compared to other parts, and used trusses into two layers depth to transfer the load. These trusses connected to the inner core and outer column at a single pin joint position to prevent outrigging. It is also closely laid to support the inner longitudinal column. The force of the truss diagonal member is transferred only by the flange at the connection area. The exoskeleton installed on the outside is primarily responsible for this load transmitted through the inner member. A diamond grade frame consists of several main layers that are fitted together to form a tightly enclosed structure. A steel structure with diamond-shaped reinforcement is the first main layer, which acts as a load-bearing element. Additionally, orthogonal steel structures are used to support existing structures. Other layers of steel structures with reinforcements form dense packed structures. In addition, fine glazing and asymmetric cladding complete the structure. The load is mainly transferred through the diamond grid structure, so they don't need to have a lot of columns installed. And as there are fewer columns, they can have more interior space. In addition, Cctv applied the continuous full facade structure or continuous tube structure across all sides of the building through a diamond grid. A continuous tube structure distributes the load applied to a location within the structure throughout the system along its length, improving stability and load-bearing capabilities. These structures can be used to resist extreme seismic and wind loads, as well as enormous stresses generated in the L-shaped and tilted parts. This structure design reduces steel use by 20%. The vertical column, diagonal member, and perimeter beam will meet at the nodes. All three members will be connected together through a butterfly plate. The butterfly plate acts to transfer the stress applied to the joint to the columns, preventing them from being concentrated. If stress is concentrated at the joint, there is a risk of brittle fracture under periodic seismic loads. Such structures must withstand minimum bending and stress concentration from maximum load, which are used to aid in smooth load transfer. When the butterfly plate is installed, the construction work first manufactures the steel part required on site and prepares them by welding them on site. After that, the partially finished parts are lifted and installed one by one. Each part is assembled with high-strength bolts to ensure high strength, and the parts are assembled and tested. After that, the parts are re-welded and reassembled by high-strength bolts. Finally, it is completed by installing a reinforcement bolt to strengthen the surroundings of the structure. This week, we studied about the elements that make up the tower and about the continuous tube exoskeleton consisting of vertical columns and truss structure inside, and the external diamond grid and the butterfly plate that connects them. Next week, we will talk about the components of cantilever beams, the construction process, and the things that had to be considered during construction.